In this lesson, we are going to introduce conics. And conics are basically slices of a cone. So if you stack two cones on top of each other and you take slices of these cones, you're going to get four different shapes. And one of them is if you take a slice at the same angle as the cone, you're going to create yourself a parabola. If you cut a horizontal slice, you're going to create a circle. If you cut a slice somewhere in between those two angles, you're going to create an ellipse. And if you cut a vertical slice, you're going to create a hyperbola. So in this, we're going to start to begin to focus on parabolas. So we have a little bit of review that we need to do in order to make that happen. And one of them is, in order to get things in the right form that you need, you're going to need to complete the square. So just a quick refresher on completing the square. Completing the square is we got to adjust the equation just a little bit. So we're going to bump the 6x over. So there's a little bit of prep that needs to happen. And then we are going to add something to this to make it a perfect square. That's what it means to complete the square. And then on the other side, we still have the 10, but because it's an equation, whatever we're adding on the left side, we should be adding on the right side as well. So to figure out how to make this a perfect square, it's all based upon this -6, the b value. We're going to take the -6 and we're going to do two things to it. So I organize it like this. So the two things we're going to do is we're going to divide it by 2. That gets us a -3, and then we're going to square it. That gets us a 9. And both numbers play a role. The 9 that you get out of this is what we're going to add to both sides. And then we're going to try to factor this quadratic. So what multiplies to 9 that adds to -6, it would be a -3 and a -3. It would be that number inside right here. So after you divide by 2, that -3 is the value that this thing is going to factor into every single time. So that was the idea, that this quadratic is a perfect square. So that means you could factor into the exact same two factors. And so we shortcut that with writing it as x minus 3 squared equals 19. And then to get rid of this square, we would square root both sides. So that would leave us with an x minus 3 would equal plus or minus the square root of 19. It's not a perfect square. And then we would subtract 3. So our final answer would be -3 plus or minus the square root of 19. Okay, so when we deal with conics and we have to get them in a certain form to graph, it's going to take completing the square. So this kind of a method is going to have to happen. Now we're going to do a little bit different than this, but basically we're going to be doing that math. So we just want to make sure you're okay with that. So one of the review is just a quick refresher on what does a parabola look like. So this is the vertex form of a quadratic. So this is your left and right shift of your vertex, and this is your up and down shift on your vertex. And remember that your left and right is opposite. And then we're going to have a line of symmetry it's easier if we just kind of do the graph, and we'll talk about the line of symmetry in here in a second. So this graph is this x plus 3 is going to shift left 3 and down 4. So your vertex is going to be -3, +4. So we'll go 1, 2, 3, 1, 2, 3, 4. And then there's two main ways to graph this. One is talking about the fact that this is a quadratic, so we do what's called outs and ups. So if we go out 1, we square that value, and that makes us go up 1. If we go out 2 and square that value, that makes us go up 4. 1, 2, 3, 4. And if we go out 3, square that value, it makes us go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or another way to do this is there's a pattern. There's a pattern in all quadratics, and the pattern is from the vertex, if there's no a value, and there's no a value to mess with our outs and ups as well. But if there's no a value, then you're basically going up 1 over 1. And then this one doesn't build from the vertex every time, it just builds from point to point to point. So it's kind of getting steeper as you go. So it goes up 1 over 1, up 3 over 1, up 5, over 1. So we can do that in the other direction. Up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5, over 1. And that is a quick refresher on graphing a parabola. Because in conics, the difference is going to be our parabola is going to potentially go that direction. And so the pattern is going to be a little bit different, and the way we go about graphing it is going to be a little bit different. But that's a very quick refresher on parabolas, and we're going to now tie this into what it looks like in the conics world.